Hello students, so here are the suggested solutions to exercise 9a and 9b on Pythagoras Theorem. 9a, in the triangle ABC, okay, AC is 43, ABC 90 degrees over here, then the length 15 cm is given, 22 and 19 centimeter. So what we need to do is we are told to find AH. We need to actually think about this in the reverse order, right? To find AH, we need AB. Because AB minus 15, we get AH. So to find AB, we need BC. So because with BC, right, how to find BC? To find BC, we need BK. So we'll start by finding BK. So using the triangle BKH, Pythagoras theorem, BK square is 22 square minus 15 square, right? Hypotenuse is 22. So that works out to 259. When we square root that, BK is 16.0935. Okay, so we got our BK, and then we add 19 to it, we found our BC, so BC is 35.0935. Once we have BC, now we can go on to find AB using Pythagoras theorem again, right? So AB squared plus BC squared gives us 43 squared, therefore AB squared is 43 squared minus BC squared, right? BC we already found, that gives us 617.45. Square root that, we'll get our AB, which is 24.85. Then minus away 15 centimeter here, we get our AH equals to 9.85, rounded off to 3 significant figures. Question 14. In the figure, okay, what we see here is that we have two triangles, large one, the DEF here and DGF here, which we need to find the area of, because by adding these two triangles together, we actually find the area of the figure, right? So let's find the area of triangle DEF first. To find the area of triangle, we need the base and the height, then we use the formula half times base times height, right? So let's find the DF, which is the base of the triangle DEF. So we need the EP square. EP square can be obtained using the triangle EP and F, right? Right angle triangle here. So EP square is 23 square minus 13 square is 360. So we got EP square. That means now we can find DP, right? Because DP square plus EP square is 31 square. So DP square is 31 square minus EP square. So that gives us 601. Square root that, we found our DP. Then we add 13 to it to find the DF, which is the base of triangle DEF. So that gives us the base DF is 37.5153. Then we can find the area of the triangle, right? Because half times base times height, so half times the base DF times the height. The height is actually EP. So we have EP square is 360. EP will be the square root of 360. That gives us 355.901. So that's the area of the first triangle we need to find. Let's find the area of the second triangle. Second triangle DGF, we need to find GF, right? So to find GF squared is DF squared minus 32 squared. So DF, we already obtained it from the first part of the question. So that gives us 383.398. Square root that, GF is 19.581. So with the GF and the 32, we can use half times base times height to find the area of triangle DGF. That gives us 313.289. Then to find the area of the figure, we just add the area of these two triangles together, and that gives us 669 square meters, rounded off to 3 significant figures. Okay, exercise 7b now again, I think. Okay, question 6. So two vertical buildings, very straightforward question. However, we need to, before answering the question, visualize where the right angle triangle really is, right? So the right angle triangle, if you look at the cursor of my mouse, is over here. This is the cable here is actually the hypotenuse. The height here is the difference between the two buildings, so it's going to be 7. And the base over here is going to be 60 meters. Therefore, using Pythagoras theorem, the length of the cable square is 16 square plus 7 squared. So to find the length, we square root it. We get 17.5 square meters. Question 8. There we fold a sheet of paper into an envelope, okay, as shown. So this is how it looks like. And then we need to figure out the length at which we apply the glue. So we are supposed to apply the glue along here, AD and BD, right? So these two lines we find the length of these two lines and we add them together, and that will be the solution. So AD squared is 8 squared plus 8 squared, which is 128. BD squared is 14 squared plus 14 squared, which gives us 392. Therefore, AD is actually square root of 128. BD is the square root of 392. Add them up together, we have 31.1. So the length to apply the glue is 31.1 centimeter. My apologies, I made a spelling mistake here. Length of the sides, not length of the size. Right, next one. A straight pole PR is leaning on the wall, right? So we are supposed to find the length of the pole. So if you look at this, the pole is actually the hypotenuse of triangle PRQ. Therefore, using Pythagoras theorem again, 4.2 square plus 1.1 square, we actually find that the length of the pole is 4.34 meters. It rounded off to 3 significant figures. Now in part 2, what happened is the pole slid down. So xy is actually where the pole is now, which means we actually know the length of xy, which is 4.3417, right? Okay, we use the values before we rounded off. Okay, so we have that. So we are supposed to find the distance yr, right? This is the distance that we are supposed to find. So how do we do that? Well, let's find qx first. Qx is 4.2 minus 0.9. That's fine, 3.3. So this length is 3.3. And then we want to find the yq, right? So yq, using the triangle yqx, the right angle triangle, Pythagoras theorem, yq yq square is actually 18.85. 18.85, what is that? That is actually this value, right? 4.3417 square minus 3.3 square, okay, which is our qx square, give us 7.96. So square root that, yq is actually 2.8213. Therefore, yr, we just subtract 1.1 meters, that gives us 1.72 meters, right? Okay, so that's all the questions that I asked you to try. I hope you have been successful. If you have not been successful and you need more clarification, do make an appointment with me and we can discuss it in further details. Have a nice day.